Another tool that's going to help us a lot when we're talking about this unit circle business is symmetry. Now let's talk about the power of symmetry in the unit circle. This time we know our angle is 5 pi 6. So we're going to start by graphing that. Here's my initial side, like always. And I know that 5 pi 6 is going to be about there. I know it's closer to the x-axis than the y-axis. So that's going to be 5 pi 6. Now I'm going to take a point on my terminal side that I'm going to line up with my unit circle. Something like that. So there's my unit circle. And same thing I've done every time is I'm going to make a right angle out of this terminal side. Or I should say a right triangle out of this terminal side. Now, we can use SOHCAHTOA because we have a right triangle. However, we need to label the angle we're focusing on first. This is the angle in my right triangle, and that is not 5 pi 6. However, it's not too hard to figure out that that is pi 6, because I have one full pi, and I subtract the 5 pi 6 that I have, and that gives me the pi 6 left over. Now you'll notice pi 6 is the same thing as 30 degrees, which means this is a special right triangle. This is our 30, 60, 90. And once again, the hypotenuse is always 1 because it's a radius of the unit circle. So then I visualize my equilateral. There's my equilateral, which means this side is 1/2, and this side is √3/2. However, the only difference I have this time is that when I'm listing my point, notice that I'm going over x. X is now negative. Because I'm in quadrant 2, my x values are negative, my y values are positive. So x is negative √3/2. Y value is 1/2. And now that we have the point done, it's not too hard to go cosine of 5 pi 6, sine of 5 pi 6. Cosine is my x value, negative √3/2. Sine is my y value, 1/2. So as you can see, even when we had something like 5 pi 6, we're still just using the special right triangles. And in fact, anytime you do any part of this unit circle, you're using special right triangles. That's all that this is. The only difference is depending on what quadrant you're in, you add negatives based on that quadrant. Now, one word I want to talk about really quickly. This little angle we came up with right there, that has a very special word. That is called the reference angle for the triangle. You can find the reference angle by going between the terminal side and the x-axis. So that does not matter where the terminal side is. Maybe your terminal side is right there. We go back to the x-axis, and that is your reference angle. Now the key is that your reference angle will always be 30, 45, or 60. So as long as you figure out what the reference angle is, you know which special triangle you're using. You do the patterns, you come up with the point, and then you write out cosine and sine. You're done. And that is the entire unit circle. So now that we understand the power of symmetry, and we've talked about the positives and the negative signs, we understand that the only important part of the unit circle is the first quadrant. Because if I know this first quadrant, then I can come over here, use whatever the reference angle is, and it's going to be the same point as this first quadrant. You just need to change the signs. So let's come here and zoom in on this first quadrant and fill in what this first quadrant is. So let's start right here. make our right triangle out of this. This one is your pi 6 or 30 degrees. Hopefully you can see your initial side to terminal side right there. That's that 30-degree angle. We know that the hypotenuse of this is always going to be 1, which means we can put together our equilateral triangle. There's our equilateral, which means this side is 1/2. This side is √3/2. So that means my x value is √3/2, and my y value is 1/2, and we're done. Now, a quick way to start to get this down, if you want to be extra fast, is the short side is always going to be 1/2. The long side is always going to be √3/2. And we can see that even if we go up here to this triangle. This triangle is our pi thirds or 60 degrees. Hopefully you can see that 60 degrees right there on our terminal and initial side. And once again, the hypotenuse, is going to be 1. So we have our equilateral triangle here, which means the short side is going to be 1/2, and the long side is going to be √3/2 because of that equilateral shape. So there's your short side 1/2, there's your long side √3/2, and now we can make our point. We go over x amount, up y amount. And once again, short side's 1/2, long side's √3/2. Now let's talk about this last triangle. This is your pi fourths or your 45-degree triangle. So this is our 45, 45, 90. And you can hopefully see that isosceles shape in those sides. Now we know that because this is an isosceles, the two legs have to be the same length. So this one is the same as this one. And we know the hypotenuse is 1. That means that both side lengths are going to be 1/√2. Here, I just realized I switched these. We've been doing X as orange. Let me fix that real quick. So now I know that this side will be 1/√2 and this side will be 1/√2 because of that isosceles shape. So at the end of the day, here's how I start to go really fast on my unit circle. I visualize where the terminal side goes. If it's a short side, the value is 1/2. If it's a long side, the value is √3/2. And if it's an isosceles, where it looks like the sides are the same length, they're both 1/√2. And that is the entire unit circle. For any angle you do, you just have to figure out what the reference angle is, pick the point that you're using. Let me write this one in here. And then add in your positives and negatives based on what quadrant you're in. So what I would like you to do is pause the video, take a second just to fill out this table. Same thing we did last time. This is just to put everything in one place to make it really quick to reference and use and study. Then after we're done with this table, in the next video, we'll practice putting all of this together and see if you can start to do the unit circle really fast in your head. Oh, and I should probably note, these are the ones we're doing. I want you to also include right here 0, what that point will be, and up here 90 degrees, what that point will be, which hopefully won't be too hard to come up with because there are quadrantal angles. So we know that at 0 degrees, we're moving over 1 in the x direction. We're not moving up and down in the y direction. And up at 90 degrees, we're not moving in the x direction, but we're moving up 1 in the y direction. Because of that, radius is 1 thing. So using that, fill out the cosine and sine columns on this table, knowing that cosine is x and sine is y. Come back to check your work. There we go. We got it all in one place. This is the entire unit circle. We just have to use reference angles to figure out the rest of it. And that is what we're going to practice doing in the last video for today. We have a couple examples where we're going to look at the other quadrants, figure out what the reference angle is, and then go from there.